9.4, we're going to spend today and tomorrow on simplifying radicals, and we'll get as far as we can today, and then tomorrow we'll kind of wrap up. But simplifying radicals is something you have to do this year. We're going to use that a lot in geometry, and then you'll use it when you get to advanced algebra as well. First thing you need to do is list the first 20 perfect squares. So when I mean by that, the perfect squares, remember, like 1 times 1 or 1 squared equals 1. 2 times 2 or 2 squared equals 4. 3 squared equals 9. So I want the first 20. So on top of your paper, list the first 20. And you're going to use those today. Anytime you're simplifying radicals, it's good to write them down on top of your paper. After you finish that, I want you to open to page 430 and complete the think and discuss on top of page 430, or take a look at it. Everyone doing pretty... Oh, that's not really in a straight line. Everyone doing pretty well on the perfect squares there? This is our 15 squared right here. Okay, this is our 10 squared. If you didn't know, perfect squares have patterns. Like if you know the previous one, like you add 3, add 4, add 3, add 5, add 7, add 9, add 11, add 13, add 15. Everyone see that pattern? So if you knew like 121 and 144 and I added 23, that means I'm adding 25 here. You add the next odd consecutive. Okay, so you add 25, you add 27, you add 29. Okay, so if I didn't know what 16 squared was, I'd add 31, which would give me 256. And 17 squared is 200. Anyone? 89. 289. Oops, 89. 18. 324. 19. 361. And 20. 400. Now the other thing to think of, if you're just double checking these real quick, like especially when I get to these down here, you know when you're doing like 16 squared, 6 times 6 is what? 36. It has to end in a 6 because 36 ends in a 6. Or 17 squared, 7 times 7 is 49. This number has to end in a 9 because 17 ends with a 7. 7 squared is 9. Okay, so if you say for 19 squared, if you got 374, well, 9 times 9 is 81. And that means this has to end in a 1. That couldn't work. Okay? 361 is probably a pretty good choice there. All right. Have we talked about the perfect squares in here? I love dealing with perfect square. I done that with you guys. It's pretty awesome. Anyway, do all of them from 1 to 120 or 126. I don't know 127. I know them all. I can do them all in my head. Awesome. Have we done that?
Yeah.
You guys should learn that. It's a very cool trick. All right. On page 430. On page 430, a radical expression. 3 things you need to know and you need to check off. Anytime you're looking at a radical expression means something like root 194. That's a radical expression. Maybe you put a variable under it. Okay? But anything under a radical symbol, that's a radical expression. A radical expression is in simplest form when all 3 of these statements are true. First, the expression under the radical sign has no perfect square factors. Tell your neighbor a perfect square. Okay, what's a perfect square? Any perfect square. Come on. 36, okay? If it has no perfect square factors other than 1, then it's in simplest form. The expression under the radical does not contain a fraction, and the denominator does not have a radical expression. So in other words, for instance, this right here is not in simplest form. Root 20. Okay, so maybe list an example for number 1. Root 20 is not in simplest form because root 20 can be broken into the product of two numbers, one of which is a perfect square. What perfect square goes into 20? Yeah. 4. We could break this into 4 times, 5. Okay? And we have to put the root symbols in there as well because it's a root. So root 20 breaks into root 4 times root 5. Why? Because root 4 times root 5 is root 20. You multiply two things together, you get that. What is the square root of 4? It's 2, and then root 5. So root 20 simplifies to become 2 root 5. If you have a calculator and you do square root 20 on it, and then you do 2 times square root 5 on it, you get the exact same value. They're equal. They have the same value. Okay, root 20 equals 2 root 5. Okay. Number 2, the expression under the radical sign does not contain a fraction. So for instance, maybe you have the square root of 20 over the square root of, or square root of 20 over 81. So now underneath your radical symbol you have a fraction. There's our fraction. Now you can break this up. This actually breaks into root 20 over root 81. Are either of those perfect? Yeah. What's the square root of 81? That's 9. What's the square root of 20 simplified? Square root of 20 simplified is 2 root 5. Okay, so that would become that. Okay, for those of you that are starting to swim, you're like, holy cow. It's a lot of stuff to try to remember. We're going to practice it quite a bit. That's why we spent a couple days on it. Okay, I just want to get the 3 rules down. The last one is the denominator does not contain a radical expression. So for instance, maybe you have 7 over the square root of 5. Okay, you look at the denominator and there's a radical in the bottom. You're like, what? That can't be there. Okay, we haven't rationalized that. And so what we're going to do is we're going to get that radical out of the denominator. Okay? Tell your neighbor how you can get it out of the denominator. Most of you probably don't know, but at least take a guess. Like, how am I going to do that? Any thoughts? Yeah. Square it. If I square this, I get 49 over 5. That work? We can't just square something. Unfortunately, if we're changing its value then. What's the one thing you could multiply something by and not change its value? 1. So let's multiply it by 1. How would that help? Bless you. Okay, well, let's change the value of 1. I'm going to say our value of 1 is this. Tell your neighbor why that's 1. Someone explain to me how that is 1. How is that equal to 1? Yeah? Yeah, when you divide, top divided by bottom, they're the same number, it equals 1. Anytime you divide something by itself, it's 1. So I'm multiplying by 1. How does this help? Well, kind of like what Annalise said. She said, well, if you square it, my assumption is that she was trying to square the bottom so she get the radical out there. Okay, well, you're on the bottom here. Now you're going to get the radical out. Root 5 times root 5. Anytime you multiply something by itself, a radical by itself, you get the thing inside it. Root 5 squared is root 25, which is just 5. When you multiply a radical by itself, you get the thing left inside. For those of you like, that doesn't make sense, well then multiply root 5 by root 5. That gives you root 25. And the square root of 25 is 5. Okay? Just a shortcut is to take the number that's in there and put it there. The other way to think about it is you're taking root 5 and you're squaring it, which that and that cancel out, so I'm left with the 5. Okay? What's 7 times root 5? That would be root 7 by root 5. Yeah, so all I do here, I can't call it root 35, but what I can do is just put the 7 right next to it. So we just call that 7 root 5 over 5. Do 5 and 5 cancel? What's the square root of 5?
25.
The square root of it. What's the square root of 4?
2.
What's the square root of 9?
3.
So if I have the square root of 4 is 2, and the square root of 9 is 3, what's the square root of 5? It's about halfway in between, right? It's close to about 2.5. So if I think of this as like 2.5, can I cancel this and this? Are they the same value? No, you can't cancel the 5s because this is root 5, which is about 2.5. You can't cancel a 5 and a 2.5. It's like me saying, hey, I got $2.50, I'll trade you for your $5. Like, that's not a good deal. Okay? Can't do that. They're not the same value. This is about 2.5, this is 5. So you can't cancel the radical. So your answer here is 7 root 5 over 5. Okay, done there. I want you guys to take a look at these problems right here. Go ahead and answer those questions with your groups there. Okay, so for those of you that are cranking away trying to figure out the answers, make sure you read the instructions. Explain why each expression is not in simplest form. You're not simplifying. You're just explaining why or why not. Why they are in simplest form or why they are not. Okay, you get about another minute. Okay, so a perfect square will go into 20. What perfect square? 4. Good. This is not in simplest form because root 4 will go into it. Well done, Jennifer. Your group gets a point. You may be wondering what the points are for. We'll talk about it later.
Oh, jeez.
Good job, Jennifer. All right. Letter B. Person number 23, who is Chelsea. Chelsea, what do you got? Not sure. Okay. Number 4, TT. Not sure? All right. Number 13, Ryan.
Jeez. Wait, number 13 on this paper.
No, you're number 13. Letter B.
Oh, crap. Okay. I'm going to say that it is simplified.
It is simplified?
Yeah.
Okay. Why?
Because it's with root of 4. Or it's, I don't know.
I'm going to give you a point for saying yes, it is simplified. It is. How come it's simplified? Volunteer. Your chance to get a point, man. Can't hurt yourself. Lily.
The denominator is an oh, never mind, I'm on the wrong one.
Yeah?
The 5 got moved, so now it's with the 4.
Has nothing to do with the 4. Yeah?
Because it fits in with all three of the rules.
What are the 3 rules?
That the expression has no perfect square factors.
Okay,
Then
okay, hold on, pause for a minute. The expression has no perfect square factors. In other words, there's not a perfect square other than the one that will go into 5. Okay, very true. What else?
the expression under the radical form is not a fraction.
Good. The expression under the radical, there's not a fraction here. Okay, you don't have a fraction inside your radical.
And then obviously since it's not a fraction, the denominator can't have a radical.
Good. So you guys, everyone remembers those 3 rules, right? These 3 guys right here? Those are the 3 rules we're checking. Okay? Well done. So yes, that applies on all 3 of those. All right. Hey, you guys got the lead, man. 2 points. Okay, person number 11. Jaden. What do you got? Letter C.
It is simplified.
It is simplified? That's not correct. Trinity?
It isn't simplified because, like rule 3, it has a radical in the denominator.
Good. It has a radical in the denominator, so it is not. Okay? So no and no. Okay? And person number 2 gets letter D. Annalise.
I said no because the expression in the radical is fraction.
Good. No, because you have a fraction in the radical. All right, you guys, anytime you have a fraction in the radical, you can break that down to root 2 over root 5. And now you have a fraction, or a radical in your denominator, so it doesn't work. Okay, very good. So, any questions on those? Hey, right now, just so you know, the early lead, we've got 3 points to 1, and no one else. You guys have none. Huh? You'll find out. You'll want points, trust me. Make sure you guys are participating. All right, here you go. You got your assignment. Take a look at it.
Yeah, I got a point.
Make sure your groupies are on top of it. Here we go. Set 1. Simplify each radical. Okay? Right now I want you to spend time on number 1 and 2. All right, we're going to go through those with actually, just start with 1. Try to break that down into its perfect squares that go into 50. Okay? You get about 1 minute to work on number 1. Go. First volunteer, what's wrong with it? What's wrong with it? Trinity?
Not in simplest form.
Why is it not in simplest form?
It's not a perfect square.
True. That doesn't mean it's not in simplest form. Like root 7 is not a perfect square, and it's not in simplest form either. It's like, what's wrong with it? TT? A perfect square can go into it. Okay? So the perfect square that goes into it, volunteer? Mackenzie? Good. So we have root 25 times, yeah?
2.
Times 2? Not 2. Root 2. Okay, root 25 times root 2. Okay? Are we good now? We've got to do one last thing. Yeah? Yeah, simplify 25 becomes what? 5. 5 times? Square root 2. That's our answer. We've now simplified it. Okay? Jaden.
Could you do like instead of 25 and 2, could you do like square root of 5 and square root of 10?
Good question. Could we just, rather than doing 5 and 2, could we do root 5 by root 10? Go ahead and talk about it with your group. Is that okay? Yay or nay? Why? Why not? Jaden, you get a point for a good question. Okay, who says yep, we can do that? Who says nope, we can't do that? Who has no idea? You're like, I have no idea if I can do that. Okay, why we cannot do it? Why can't we do that? Yeah. Yeah, neither of these are perfect squares. So the only numbers you want to break 50 into are ones that are perfect squares. So the only perfect square that goes into 50 is 25. So we don't want to use 5 or 10 because neither of those are perfect. They don't help us. The 25 helps us because then we could take the root of that to get 5. It's a very good question. All right. Any other questions? Why don't you try number 6 right now? Number 6, so the one right below it. It's always a good strategy to write the perfect squares at the top of your paper. Okay, let's see. Share with your neighbor what you got. Make sure everyone's on the same page. All right, person number 9. Mackenzie, what do you got?
I got the root 16, the root 3. Oh wait, never mind.
Did you do this one?
Yep.
Okay. How about this one? What perfect square goes into that? Oh, Trinity?
Would it be the square root of a radical of 100 and then radical of 3?
It would be. That's totally radical. Okay, root 100 by root 3. Root 100 becomes 10 and root 3. How many got it? Well done, eh? Okay, question?
It's okay if they're flipped, right? Like if it's like you do the square root of 3 and square root of 100.
Yeah, so if you wrote you wrote it like this? Like that?
Yeah.
Yeah, that's okay. We at the end, go ahead and put the whole number in front, though. Okay? Yeah.
That's a pretty good question though, right?
That was a good question.
Is it like, is there a point?
Point worthy? Yeah, it's probably point worthy. It's a good question. Yeah, you guys got a point.
You get 2 points?
No, but I got you a point. The lead right now is still with
Wait, how many points do we have?
right there. There are the points.
Where's the 1 point? Where's the 1 point?
1 point is Brendan's group. Okay. Or Cole's group or Patrick's group. I don't want to assign values to groups. Okay? Or assign names to groups. There we go. You got 1 through 10. You get 5 minutes to work on as much as you can on 1 through 10. Make sure you ask questions as I walk around. Hey, can I have your attention up here real quick? You guys, I don't want you to sit there and struggle so much that you can't. I mean, you're taking forever trying to do division here. You know your perfect squares. Okay, you know that 1 we don't use because it goes into everything, but you know, you got 4, 9, 16, 25, 36, 49. I would list all those on top of my paper, and then as you're trying to figure out if any perfect squares go into 48, you could use a calculator. It's okay to take it out and say, okay, I have 48, and I'm going to divide it by 4. Does that go into it? If you don't know, yeah, it does. It goes in 12 times. Okay? And you're like, well, 12, I know 4 goes into that as well. You could try, if 4 goes into it, what other perfect square might go into it? Which of these perfect squares does 4 go into? 16. What else? 36. Okay, and you guys get a point. You're actually participating. Okay, you have 48 divided by 16. Hey, it goes into it 3 times. So take the biggest perfect square. Okay, so when I'm breaking this down, this is root 16 times 16 went into it 3 times, root 3. And root 16 is 4. We have 4 root 3. Now let's say you stopped and you said, well, I found out that 4 went into it. So I broke it in. I said it's root 4 by root 12. That's fine, except for now you've got to break apart root 12. You've got to say, well, 4 goes into that. That becomes root 4 times root 3. This piece is 2. I'm now done with it, so I'm going to circle it. I'm done with the 2. This part is 2, so I'm done with that. And then root 3 I can't simplify. Those are my pieces. I have 2 times root 3. Well, 2 times 2 is 4. So that's 4 root 3, which is the same answer we got right there. Okay? Yeah?
Isn't this kind of like the trees? Well,
Yeah.
not really, but like it looks like the trees.
It looks like the factor trees, yeah. Yep. Okay, questions on that? It's okay to use the calculator to figure out what perfect square goes into them. But what I don't want to see is this. 48, root 48 is that. And then put that answer. That, you guys can't see that answer, but that's not, when you do root 48, you don't do that. You get 6.92 and you're done. That doesn't work out. You can say 48 divided by 4. Hey, it goes in, whoops. Unbelievable. Okay, it goes in 12 times and use that, or you could do 48 divided by 16. It goes in 3 times and use that. Okay? All right. Any other questions on set 1? Yeah.
Number 10.
Number 10, root 98.
Yeah.
So are you testing your perfect squares?
What?
Are you testing them up there?
Yeah, we couldn't figure out.
You got it? You gotta go quite a ways to get that one. Jaden? Number 5? Root 75? What perfect number goes into that? Richard Sherman style. Three quarters? 25. Yep. All right. Okay, you guys, we're going to skip set 2 for a minute. And I want you to jump to set 3. Okay? We're going to skip set 2 and I want you to jump to set 3. And the first thing you need to do on set 3 is this. You need to learn that you can break apart radicals. Okay, so all this stuff in here, I'm doing 49 times x squared. So I'm going to put a multiplication sign in between those two things. And I can do 25 times y to the 4th, so I'm going to put a multiplication sign right there. Okay? And I can do 50 times p to the 6th, so I'm going to put a multiplication sign right here. And what that's telling me is every time I do that, I put those little multiplication signs. And I can do that because there's my numbers and my letters. Okay? What I can do is I can break that apart. I can say, well, that's actually root 49 times root x squared. Okay, I want you to break apart these next 3. Break them apart just like I did that one. Okay, how many got that? Not too bad, right? What part can I simplify in number 21? Yeah. What is the square root of 49? Everyone write it down. Okay, what is it? 7? Good. You guys have a point again. All right. Okay. And this one? Yeah? 5? Okay. All right. Everyone simplify root 50. Break it apart. Okay. What do you got, Ayla? What's that? 5 times square root 2. So you broke it into root 25 by root 2, and which gave you 5 root 2. Everyone good? Okay, so really the only part you have left are the variables, right? Variables are easy in perfect squares. They look kind of tough, but they're pretty easy. If the variable has an even power, you just cut the power in half. So the square root of x squared is, it's x. Just cut the power in half. So that simplifies to 7x. Square root of y to the fourth. Tell your neighbor what that is. Okay, what is it? Y to the second. You just cut the power in half. P to the sixth is? P to the third. Okay? And we rewrite this one as 5p to the third root 2. Okay. So what's the next logical question that comes up? TT? Yeah, what happens if it's not like an even number? Like I have a to the fifth. Well, everyone simplify root 72 first. And we'll put a to the fifth here. Simplify root 72. It's a close match. Person number 6. Cool? You got it? No? Hold on. We're tied up with 2 groups right now. Jens isn't here. Asher? No? Torres? Huh? Root 3, no, root 9 times root 8, you're right, which is 3 root 8. Good. Okay. A to the fifth. Yeah?
Can it be like 36 and square root 2?
Ooh, that's close. What is the... Yeah. No. What is the first the closest even number that does not go over 5? 4. This is a to the fourth times. How do I get a to the fifth?
2.8, 2.5.
No. A to the fourth times what? Times a to the first. What is the root of a to the fourth? A to the second. And a to the first we just call root a. You've now simplified a to the fifth. You put it all together now. So you have 3a squared and root a 8a. You put the roots in the same radical and the stuff on the outside. Yeah.
Why is it 5 p to the third and then root 2? Why wouldn't it just be 5 root 2 then p to the third since it's...
Well, because the p to the third is the root of p to the sixth. You just cut it in half. Hey guys, anytime you have an odd number, you take the closest even number. So like this one right here, let's break it apart. We have root 8 and we have root d cubed. Okay, root 8. What is root 8? Mackenzie? Root 4 by root 2, which becomes 2 root 2. D to the third, what's the closest even number? Yeah? Yeah. D squared times root d. Okay? Now we always have a single, okay? We always have a d to the first, or to the first, just like here. This is 2 root 2. Root of d squared is d, and then we have root d. Put that in the correct order, it's 2d root 2d. Okay. Questions? Here's what you need to finish tonight. You need to go through set 3, which means you need to complete all of this set 2 now. Now you're looking at set 2. Set 2 doesn't have any numbers other than the powers. Okay? Now for those of you looking at it, you should be able to do this one pretty easy. and this one, and this one. In fact, these three you should be able to complete within the next minute. Right? These are all perfect squares. If you can't complete those right now, you need to raise your hand. I'll be around. Okay? Hey, guys, TT just pointed out something to me. We should have simplified root 8 here. But that's okay. I'm not going to sweat that right now. This part should have broken into root 4 by root 2. We should have simplified it one more step. Okay? Good job, TT. You guys get a point for that. Well done. Found a mistake. Any questions on set 2? How about when we get down here? Say like number 17. X to the 4th, y to the 5th. What does that break into? Dude. What two parts could we break that to? Yeah. Oh, right here? Yeah. So first, let's break it to this. X to the 4th and y to the 5th. Okay? And then you want to get to an even power. So we've got y to the 4th and y to the 1st. Okay, these break apart. Okay? So we've got to break this into an even power. We always take the power right before it. It's always the closest even number. Y to the 4th is root of y to the 4th is y squared and root y. X to the 4th is x squared. So we get x squared y squared root y. Okay, your assignments through number 25 tonight. Get those done, please. Okay. Winner today is this group right here, over there.